Okay, I got a story for you guys. A long time ago, somebody said it's not appropriate to have radicals in the denominator. And I don't know who that somebody is, but because he said that's not appropriate when we have radicals in the denominator, we had to come up with a way to get them out of there. Get the radicals out of there, but make the expression equal the same thing. And so we found a method. And here's how this method works. I'm going to show you how to do it on these two problems right here. What you need to do is you're going to multiply this thing I have an error towards by 1, but it's not going to look like 1, it's going to look like something else. We're going to multiply it by the square root of 3 over the square root of 3, which is equal to 1, isn't it? Square root of 3 divided by square root of 3 is 1. So we really haven't changed anything, but it's going to look a little different. And check out what happens. Remember, when you're multiplying these things, 1 times square root of 3 is just square root of 3 on top. But what is the square root of 3 times the square root of 3? Well, that's the square root of 9, and we all know that the square root of 9 is equal to 3. So what we have in the end is the square root of 3 over 3. And look, these two things are identical or the same, but they look different. And now there are no radicals in the denominator. Okay. Now we're going to do the same thing for this problem right over here, b, but it's a little bit different. You don't multiply by the square root of 3. You got to multiply by the conjugate. That's what it's called, the conjugate. And this is what the conjugate is. You look at this, and you look at specifically the radical. And if the radical had a positive or an addition in front of it, you multiply by the same thing but a negative in front of it. If it was a negative there, you multiply by a positive. So in this case, we're going to multiply by the negative. So we're going to multiply by 1 minus the square root of 3 on top and bottom. 1 minus square root of 3. Okay. Now what you'll notice here is we have to multiply two binomials. And that's why it was good that we learned how to multiply in the previous problem. So let's make our quick box and multiply these two binomials on the bottom. Okay, we're going to multiply this times this right here. So I got 1 square root of 3, 1 negative square root of 3. That's 1 square root of 3, negative square root of 3. Oh, look at those cancel off. And then negative square root of 9, which actually gives us negative 3. Combine these two things right here, and we get negative 2 for our denominator. So, with that in mind, let's put this all together. Okay, let's do it in blue. I'm going to have, we'll bring this right down here. I'm sorry, I ran out of room. I should have done this in a different way. We got 2 square root of 1 minus square root of 3. That's the numerator all over. We found the denominator was, what was it? Negative 2. Negative 2, right? And what can this 2 and this negative 2 do? Well, they can cancel. See you later. And so really what we have is negative, because it's negative right there, negative 1 minus square root of 3. And this, if you distribute this negative in here and in here, we really have negative 1 plus the square root of 3. There's our final solution to this one right there. And that's how you rationalize the denominator when you either have just one radical by itself or when you have a binomial that contains a radical.